In this video, we will generate the damp vibration or the damp cosine and its Taylor series expansion. So we begin with the values of V, which is 0.3 to 0.5. So data validation, list of items from 0.333 to 1. So we can start with 1. Likewise, the value of W, which is data validation, list of items from 1 to 3. So copy this and paste here. We can start with 1 also. And we copy this, so paste it here and change the color to red. Now we generate the dataset of the damp cosine vibration. So this is called to array formula. Exponent minus V times X. So that's minus Vx. That's the first part. Times. The second part is cosine Wx. So cosine W times X. That's the first part, the dataset of the damp cosine. We continue with the Taylor series expansion, which is the summation of a times x to the power n, where the value of n is from 0 to infinity. 18 is good enough. And the value of a, the coefficient a, is the real part of the minus v times wi raised to the power n over n factorial. So this will be starting with minus v plus wi. So minus complex minus v comma w. That's minus v plus wi. We continue raised to the power n. So that's IMPOWER. IMPOWER raised to the power n. That's the first line. But because we are filling up the rest, then we use array formula. Array formula. Array formula. And instead of D3, we'll raise it to the power n up to 18. Next, we want the real part. So this is, you only want the real part. So IMREAL. You want the real coefficients. Enter. And finally, we divide this by n factorial. So this will be divided by factorial n. Now we complete the Taylor series expansion. So array formula, series sum of the x values raised to the power n, where n start from 0, incremented by 1, and the coefficient will be this range. And we'll chart this. Insert chart. And we use scatter chart. We don't need this space. We don't need the title. But we show the trend line. The type of the trend line, polynomial. The degree 8. For the label, use the equation, and for the legend, position at the bottom. Here's our trend line and polynomial of the expansion and the function of damp cosine or decaying cosine. We calculate this polynomial regression coefficient using LINEST. To do that, we complete the LINEST matrix, starting with the power. Is transpose 0 to 8. And the elements of the matrix. So this will be array formula of the x values raised to the power 0 to 8. And now we use LINEST. Data y and data x. Again, we also use LINEST here. Data y and data x. And now we can compare. So coefficient of x to the 0, 1. Coefficient of x, negative 1, which is also negative 1. Coefficient of x squared, 5.01 times 10 to the minus 4. Coefficient of x cubed, this is 0.335, 0.335. Coefficient of x to the 4th, that's 0.17, this is 0.17. Coefficient of x to the 5th, that's 0.0375, 0.0375. Coefficient of x to the 6th, that's 3 times 10 to the minus 3. This is 3 times 10 to the minus 3. Coefficient of x to the 7th, 2.54 times 10 to the minus 4. And coefficient of x to the 8th, 4.99 times 10 to the minus 5. Suppose I change this to 2. I will change this also to 2. I'll change this to 3, 2.5. I will also change this to 2.5. Change this to 0.33. Then I'll change the red one to 0.33. Change this to 0.4. I'll change this to 0.4. Change this to 0.5. And this also change to 0.5. So this completes the use of Taylor-Maclaurin series sum, LINEST polynomial regression to generate the decaying cosine.